Hi everyone, it's Nono here, and this is Nono My Life. I want to welcome you one more week to my live stream. In case you don't know who I am, I'm Nono Martinez Alonso, and I do creative coding and work with machine intelligence here in this live stream every Thursday around 12 p.m. EST. Today we're gonna have a short session, so let me set up here the slide deck. We're gonna have a short session. Before we get started, I'll encourage you to support the channel by liking this video. And if you're not subscribed yet, you should maybe follow us in case you wanna get notified when I go live next or when I upload new videos. Today I wanna celebrate that we have reached 900 subscribers. I want to thank you for following along and for collaborating with this project, and also for all of those of you who are also in the Discord community. You can join at Nono.mas as Discord if you're not there yet, or follow that QR code up the top of the screen. Again, thanks for being there. And just as a recap, last week we did live stream 47. We looked at React hotkeys and React state. We looked at an overview of how to set those up and also recorded tutorials that will be out in the coming future. And you can access those. The link there is not okay, but you can access as nono.mas/live/47 to watch that live stream. And as always, submit questions to the Getting Simple podcast at gettingsimple.com/ask for the last episode or any previous episodes. And we're gonna skip the goals today, and we're gonna go straight to see what we're gonna take a look at today. I don't have a lot to cover today, but we're gonna see a brief mention or announcement of the Laravel 101 playlist that I'm building. And also we're going to do quick work session on the intelligence and sketching project that we're doing here on the live stream week after week. And so the Laravel 101 playlist is a playlist on how to get started with Laravel. And over the past week, we've released one video a day, and we have a video on how to create a Laravel app from scratch with Composer or with the Laravel CLI tool, how to serve Laravel apps with Artisan and Valet. This is to serve web apps written with Laravel in your computer to test them and be able to develop. How to create custom Laravel commands in case you want to, automate tasks or maybe create little programs to do things on your machine. Then we have the parse CSV data from Google Forms with Laravel, and then a follow-up on storing CSV data in a database with Laravel. This is a process that allows us to build more advanced commands in which we're reading a CSV file, we're parsing the CSV into PHP arrays or objects, and then we're manipulating that data and even storing it in a database. And then I'm going to make a quick introduction here because we'll edit this video separately. Hi everyone, it's Nono here, and this is another work session of the Intelligence and Sketching project. We're going to get started. Today we're just going to see an overview of pixel to style to pixel. We're going to, not really an overview, we already saw that, but we're going to dive into it a bit as I want to try to discover how to train the network with your own data set. I've been playing around offline, not on this live stream. I've played a bit on this live stream, but I've been playing a bit more offline to do a bit of, generate some images with some pre-trained models, but I want to test this and I want to learn how to retrain with custom data sets. So without further ado, let's go to see the code and see if we can do something. We have around 20 minutes today or 30 minutes to take a look at that. So we won't cover too much, but stay with me if you want to see what we do. Also, I will invite you to say hi on the chat. Tell us where you're connecting from and what you're looking for to learning from this live stream. All right, so I'm gonna just type a comment there. Hi everyone. Looking at all right, so this just a quick note on, we already have 900 subscribers. Thanks again for being there. We have many playlists. The one I was commenting on today was Laravel 101, and we have playlists on Runway ML, Python, workflows, web development, and many other things. So I'll invite you to browse through, and I'll be always happy to hear what videos or what playlists you're enjoying the most. Okay, so let's go. This is Eladridge slash pixel to style to pixel on GitHub. It's an open sourced machine learning algorithm. And we go here, we can see a bit more information. I released a really quick video seeing some of the things that were mentioned here, but maybe we can go again over this. They present a generic image-to-image translation framework called PSP, or Pixel to Style to Pixel, based on a novel encoder network that directly generates a series of style vectors which are fed into a pre-trained StyleGAN generator, forming the extended W plus latent space. We first showed that our encoder can directly embed real images into W plus with no additional optimization, and we propose utilizing our encoder to directly solve image-to-image translation tasks, defining them as encoding problems for some input domain into the latent domain by deviating from the standard invert first. Edit later methodology used with previous StyleGAN encoders. Our approach can handle a variety of tasks even when the input image is not represented in the StyleGAN domain. We show that solving translation tasks through StyleGAN significantly simplifies the training process, as no adversary is required, has better support for solving tasks without pixel-to-pixel correspondence, and inherently supports multimodal synthesis via resampling of styles. Finally, we demonstrate the potential of our framework on a variety of facial image-to-image translation tasks, even when compared to state-of-the-art solutions designed specifically for a single task, and further show that it can be extended beyond the human facial domain. All right. So the novel proposal of this network is this PSP encoder, in which an image is encoded or mapped, and then it's mapped to style vector, right? I think, if I'm not wrong, this W1 vector, it says here it has 18 features mapped to style. You actually get a 512 element vector, which is just like 512 floating numbers. We've seen that, I think, in previous videos on the channel. And yeah, hello Sajef for connecting online. This has been a bit of an unannounced live stream. I didn't know if I was gonna have time to do it today, but here we are. Even if it's short, I just want to cover a few things. Okay, so the part that I want to try to see today, if we can read something of, is retraining, so model retraining. Not sure if that is written here, but we're gonna try. So as we've seen before, there is this inference playground notebook that they provide us with, and I've been playing, as I mentioned before, I've been playing with this notebook offline. I could show actually some of my investigations. Let me see if I can find them. Hi everyone. Okay, all right. So these are my first tests with crops from the None of My Life channel. So from the live streams, I've cropped faces, and then this is something that they call celebrity super resolution model. And what it tries to do, if you input a pixelated image of a celebrity, it's supposed to enhance the quality. If you input somebody who's not a celebrity or who's not on the model, like me, what you get is just some weird result. It generates a face that has some features from the celebrities dataset, but it's not really anything from there, right? And what was interesting in this experiment is that they also load this program that automatically crops and centers the face, right? So if you input an image and the face is on the top right or in the top left or something, it's not centered. It crops it and then it places it properly. And that actually pre-processing your input data or your data set like that, like normalizing all the data set samples makes the training a lot better, because basically what you can see here is that the eyes are always on the same location, right? And the mouth and other features move, but the eyes are always on the same location. And then here's another test that I did, which is in video. So let's hear that. Hi everyone, it's Nono here, and this is a test of pixel to style to pixel. So, of course, the voice is my voice and the video on the left, but on the right is me mapping or like inputting PSP, into the PSP framework, each individual frame and then reconstructing the video. So the process here is the video on the left is a video recorded with my webcam and has audio. So I extract one frame, so 30 frames per second as images. I do a batch inference with PSP on those images. I download them from Google Colab, and then I make another video and attach the original audio with FFmpeg. So it's a workflow we're not going to see today, but I just wanted to show you these two tests that I've done offline. We might be able to see some of these things some other time. Okay, so that's PSP, and that's just using the notebook that they provide here. But my intention, right, what I want to try to learn is how to retrain this model. And yeah, how to build your own. So this is the inference notebook, and we have pre-trained models. So the one that I was using is this one that is mentioned here. So super resolution, PSP trained with the Celeb AHQ dataset for super resolution up to 30 times downsampling. All right, so 25, blah, blah, blah. We don't care about these. And, oops. Okay, what do we have? What else do we have? Training. All right. So currently, we provide support for numerous datasets and experiments, encoding, frontalization, etc. Refer to config paths, config to define the necessary data paths and model paths for training and evaluation. Refer to transforms config for the transfer defined for each dataset experiment. Finally, refer to data configs for the source target data paths for the train and test sets as well as the transforms. If you wish to experiment with your own dataset, you can simply make the necessary adjustment in data configs and transfer configs to define your own data transforms to define your data path. As an example, assume we wish to run encoding using FF. So this is a Flickr faces high quality data set. We first go to paths coding py and define this. So this is FFHQ, path to FFHQ, blah, 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 Philip test A, blah, blah, blah. Transforms for the experiment are defined in the class encode transforms in configs transform config. Finally, in config we define when defining the main training script can be found at scripts train.py. Intermediate training results are saved to ops expdir. This includes checkpoints, train outputs, and test outputs. Additionally, if you have TensorBoard installed, you can visualize TensorBoard logs in here. Training the PSP encoder. All right. Super resolution. Additional note. See train options for all training specific flags. See test options for all test specific flags. You may do so using checkpoint path. By default, we assume the StyleGAN used outputs images are resolution. If you wish to use a StyleGAN, add smaller. By default, we assume that the StyleGAN used outputs images. If you wish to use blah, blah, blah. Okay, if you wish to generate images from segmentation masks, please specify label nc equal n and input nc equal n, where n is the number of semantic categories. Similarly, for generating images from sketches, please specify label nc and input nc. Specify nc equals 0. The default value will directly use the RGB colors as input. This is important because we might have to So I'm gonna save this into our slides. We'll have to continue some other time. I'm not gonna have a lot of time today to go through this, but it's definitely a good first start for me to be reading this thing. Let's just put it here. Pixel style to pixel. Okay. Identity similarity losses in PSP, winter facial identity loss, work face, or social recognition, or facial recognition. Right. We'll also save this. Okay, so what else? Weights and biases. This is a platform for to save analytics and training process and things like that. So yeah, if you don't have an account, probably you won't be able to get in. Okay, in testing, inference, blah blah blah. All right, so we do need to learn how to use these configs. So data configs. We need to add our data sets here. Paths config, dataset paths, model paths, and transform configs. I'm not sure what these transforms mean. Random, horizontal flip to tensor normalize. Okay, so this is that the encoder, the PSP encoder works with 500. Okay, so this is encode transform, frontalization transforms, seg to image, super res, seg to image, sketch to image transforms, resize. So you can see that there we don't randomize horizontal flip. Sketch transform, GT ground truth train, source, test, inference. Okay, so let's also put that there. Hello, Bea. Glad to see familiar faces connecting. And okay, so I guess we're building the slides for what could be an in-depth training share out when I learn how to do this, but I'm not there yet. Okay, and let's now see. So we have the train dot py. So this would be training. Okay, scripts train.py. Okay. This file runs the main training validation loop. Coach. From training.coach import coach, options, train options, options, train options, right? And then training coach. Okay, what is this coach? Okay, so this is the actual training code. And this is train. Self-train. Okay. Yep. So we'll spend more time trying to understand this. Okay. So I'm trying to. So I'm trying to see where these data sets are sketch to image. So these are the pre-trained models, but it doesn't say anything. So this is just the PyTorch model. But this code doesn't say anything about about the data sets. Okay, let's put a comment here. Let's first see. All right. I don't think we're gonna find this today. Hey Rob, nice to see that you're around. Thanks for popping by. It's gonna be a short one today, so you're not missing much. Right, we found something here. Okay, we found something. Okay, so I found this sketch simplification script that probably we're gonna have to test to see what it does, but path to sketch to GAN. Okay, well, post a question here. Mm, we're gonna see. Mm, All right, we got Mr. Gamer. We got somebody here who's spamming. All right. All right. Okay, let's submit this issue, and I'm gonna call it a day, a bit earlier than usual, but I said we didn't have much time, so I'm gonna go here really quickly, like, and again, I'll let you know that you can support the work that I'm doing here on the channel by liking this video, and that you can subscribe if you're gonna get notified when I go live next or when I upload new videos. Join the Discord community at None of the Mazda's Discord if you wanna join the conversation. And yeah, thanks a lot for watching, and I'll see you next time. Bye, and don't forget to check out all the other playlists and videos and previous live streams if you're new.